Next question, a GP consists of an even number of terms. GP has even number of terms. If the sum of all the terms is 5 times the sum of terms occupying odd places, then find its common ratio. See, here it is given that there are even number of terms. Okay, so here we have to find the common ratio, and our condition is the sum of all the terms. Okay, all the terms in GP, that is equal to sum of the terms which is occupying in odd places. Okay, so let the number of terms be be 2n, because see, here it is given that there are even number of terms. Okay, so it is better to take 2n. 2n means it is always even, right? Okay, so here if it is 2n, there are 2n number of terms, then what is the sum? Sum we can write as 2n, that is equal to, okay, so we will write the GP, okay, sequence a into, okay, first term a, second term a r, third term a r square, then a r cube. Okay, r is the common ratio, a r raised to 4, a r raised to 5, etc. a r raised to n minus 1, right? Okay, if there are 2n terms, then 2n minus 1. Okay, now here see, it is given that sum of all the terms. Okay, so first we will write sum of all the terms. There are 2n terms, so yes 2n, sum to 2n terms, that is equal to yes 2n, that is equal to a into r raised to 2n minus 1 divided by r minus 1. Okay, here it is. Okay, next see, if there are 2n terms, that is here it is given even number of terms, then how many odd terms are there? Means how many terms occupying in odd places, that is n, right? See, suppose 1, 2, 3, 4, 5, 6, there are even numbers, right? Even number of terms, that is 6 number of terms. Okay, so how many odd places? 3 odd places, right? So here it's half. Okay, so here n terms are there, right? So, and see, next, see, first odd place, that is first term a, next odd place is third term, right? So a to ar square. Okay, next is ar raised to 5. Okay, first term, next third term, next fifth term, right? See, ar square, next ar raised to 4. So here in this case, what is the common ratio? R square. First term is a. First term is a, and common ratio will be r square. Okay, in odd places. See, here first term, odd places means first term, next third term, next fifth term, next seventh term. So in this case, the common ratio is r square, so that we can write the sum Sn is equal to, okay, because there are n terms, okay, half of 2n, okay, that is equal to a into r. R is nothing but r raised to r square, right? R square raised to n. Okay, sum formula. What is sum formula? Sn is equal to a into r raised to n minus 1 divided by r minus 1. Okay, that is sum to n terms. See, here also sum to n terms, but here common ratio is r square. See, a into r square is ar square. ar square into r square is ar raised to 4. Right? So common ratio is r square, and first term is a. Therefore, sum is a into r square, that is in place of r you should write r square raised to n minus 1 divided by r square minus 1. And it is given that, see, the condition is the sum of all the terms is 5 times the sum of terms occupying odd places. That is S2n is equal to 5 times of Sn. Okay, that is, substitute this. Here we have to find the common ratio. So S2n is nothing but a into r raised to 2n minus 1 divided by r minus 1, that is equal to 5 into Sn, that is a into r square raised to n, that is nothing but r raised to 2n, right? R square raised to n is r raised to 2n minus 1 divided by r square minus 1. See here, a cancelled, r raised to 2n minus 1, r raised to 2n minus 1 cancelled, and see this one, how can we write? 5, 1 by r square minus 1. It is in the form of a square minus b square. A square minus b square is nothing but a plus b into a minus b. So here we can write it as r plus 1 into r minus 1. Okay. So that, see, r minus 1 cancelled. So here remaining 1. Okay. So 1 is equal to right side 5 into side 5 divided by r plus 1, that implies take r plus 1 here, so r plus 1 is equal to 5, that implies r is equal to 5 minus 1, that is equal to 4. So what is the common ratio? Common ratio is 4. Next question is, show that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1 to 2nth term is 1 by r raised to n. Okay, see here, first of all, we have to prove this ratio is 1 by r raised to n. The ratio of sum of first n terms, okay, that is first n terms, so first term, second term, next nth term, okay, sum of these terms, and to the sum of terms from, see till here nth term, okay, after that n plus 1, next n plus second, okay, next n plus third term to 2nth term, okay, this sum of these terms. So we have to find the ratio of this sum of these to the sum of these, okay, that is sum of first n terms of a GP to the sum of from the terms from n plus 1 to 2n, okay, that we have to find. See, for that, first of all, let us take, let a be the first term and r be the common ratio, okay. Then what will be the sequence? That is GP, AR, AR square, AR cube, AR raised to 4, etc. AR raised to n. Okay, if there are n terms, that is AR raised to n. So here, what we have to find? We have to find the ratio, right? Ratio. That means ratio of sum of first n terms. So ratio is, the ratio is equal to sum of first n terms, that is a plus AR square plus AR cube plus etc. plus AR raised to n minus 1, right? If there are n terms, so the last term will be AR raised to n minus 1, okay? Don't be confused, because first term is a, no, r is starting from second term, right? Okay, here that is divided by, okay, ratio is sum of first n terms to the sum of the terms from n plus 1 to 2nth term. So here, from here, the sum is starting from n plus 1, right? So a into r raised to n, okay, because n plus 1, see, first term there is no r, isn't it? So that means a r raised to 0, okay, subtracting 1. So here also starting from n plus 1, okay, so r will be n plus 1 minus 1, that is n, okay. So a r raised to n plus a r raised to next n plus 1 plus a r raised to n plus 2, etc. plus a r raised to 2nth term. See, we know that nth term is a r raised to n minus 1, okay. So 2nth term is a r raised to 2n minus 1, okay. Now here, see, Okay, consider this denominator. Okay, in denominator r raised to n is common, isn't it? See, we can take r raised to n. See what we will get. Let's see. First, that is numerator is a plus ar square plus ar cube plus etc. plus ar raised to n minus 1 divided by take r raised to n outside. Okay, so that we will get c a remaining a plus see when we take taking r raised to n outside means dividing by r raised to n, so that we will get a r raised to 1, isn't it? A r raised to n plus 1 divided by r raised to n plus 1 means, sorry, r raised to n means write a as it is, okay, a into r raised to n plus 1 minus 1, isn't it? That is the power rules, okay. R n plus 1 minus 1, so n minus n cancelled, so a r. So here it is a r plus a r square, okay. Taken r raised to n outside, that is divided by r raised to n plus etc. plus, okay, what is the last term? Here taken r raised to n outside, that is divided by r raised to n. So here a into r raised to 2n minus 1 divided by r raised to n means a into r raised to 2n minus 1 divided by r raised to n means that is minus n. Okay, in your small classes we have already studied, right, power rules. Okay, so here r raised to 2n minus 1 divided by r raised to n, that is into r raised to 2n minus 1 minus n. Okay, so it will be a into r raised to 2n minus n is nothing but n minus 1. Okay, so here we will get a r raised to n minus 1. See, these are same, right? Okay, so this will cancel. This will cancel. So the remaining 1 by r raised to n. Hence it is proved. Next topic, relationship between arithmetic mean and geometric mean. Last topic of this chapter, arithmetic mean and geometric mean. See, let us take two real numbers, any two real numbers a and b. Then arithmetic mean am is a plus b divided by 2. Okay, that means that's average. Okay, so arithmetic mean of a and b is a plus b divided by 2, and geometric mean of a and b is square root of ab. Arithmetic, here a and b are any real numbers, positive real numbers, okay, and therefore their arithmetic mean of two numbers, that is a and b, is a plus b divided by 2, and in meanwhile geometric mean is equal to, geometric mean of a and b is square root of ab. Now let us see what is the relationship between them. Okay, see here we can say arithmetic mean minus, let us find arithmetic mean minus geometric mean, that is equal to a plus b divided by 2 minus square root of ab. Okay, that is nothing but a plus b after simplification 2 minus 2 root ab divided by 2. See, this one we can write this one as square root of a minus square root of b whole square divided by 2, isn't it? A minus b whole square, it is minus 2ab, right? So here, see, let us expand this one. A minus b whole square form, okay, root a square a itself, right, plus b square, that is root b square b, okay, minus 2ab, a minus b whole square formula, a square plus b square minus 2ab, right? So root a square a, root b square plus b, okay, minus 2ab, that is 2 into root a root b, okay, divided by 2. So it is the relation. So it's a square, so it is always greater than or equal to 0. Here is a question based on relationship between arithmetic and mean and geometric mean. If AM and GM, arithmetic mean and geometric mean of two positive numbers A and B are 10 and 8 respectively, find the numbers. Okay, here it is given AM is equal to, arithmetic mean is equal to 10 and geometric mean of A and B is 8. That is, arithmetic mean of A and B is A plus B divided by 2, that is equal to 10, and geometric mean is square root of AB, that is equal to 8. So here we will get A plus B is equal to 20 and here AB is equal to square on both sides. Okay, by squaring on both sides we will get AB is equal to 64. Okay, next see here we have A plus B and AB. We have to find A and B, values of A and B, right? So here we will apply some identities which we studied earlier. So here A plus B, so we know that A minus B whole square is equal to A plus B whole square minus 4AB. Okay, that is, here we will get A minus B. So it is equal to, substitute A plus B value, that is 20 whole square minus 4 into 64, that is 400 minus 4 4s are 16, 4 6 are 20, so 256. Okay, so that is equal to, so A minus B whole square is equal to 144, right? 144. So A minus B is equal to plus or minus 12. See here now we have A plus B and A minus B. See, from these two equations we will get A and B. That is, A plus B is equal to, A minus B is equal to 12. Then cancelled. So 2A, add these two, by adding these two equations we will get to 2A is equal to 32. Okay. So A is equal to 16 and B is equal to, substitute here. So A is equal to 16, then B will be 4, right? 16 minus 4. So B is equal to 4. A is equal to 16 and B is equal to 4. Next question is, if arithmetic mean and geometric mean of roots of a quadratic equation are 8 and 5 respectively, then obtain the quadratic equation. Okay, here we have to find the quadratic equation and their roots are given. Okay, so here, and arithmetic mean of roots of quadratic equation and geometric mean of roots of quadratic equations are given. So here first of all, okay, let us write arithmetic mean formula. Okay, arithmetic mean of roots of a quadratic equation. So let us take, let A and B be the roots of required quadratic equation. Okay, let A and B be the roots of required quadratic equation. Then arithmetic mean is equal to A plus B by 2. Geometric mean is equal to square root of AB, and it is given that arithmetic mean is 8. So 8 is equal to A plus B by 2 and geometric mean is 5 is equal to square root of AB. So here we will get A plus B is equal to 16 and AB is equal to 25. Okay, now here see we have got A plus B is equal to 16, AB is equal to 25. See how to write the quadratic equation. See, quadratic equation is of the form x square minus sx plus p is equal to 0. That means here s is the sum of roots. Okay, and p is nothing but product of roots. Okay, here s is sum of roots and p is the product of roots. So it is enough to get these things. Okay, so no need to find a and b separately. Here if we get sum of these a and b, and here a and b are nothing but roots of required quadratic equations, right? So here we have got the sum of these two roots and product of roots. Now directly we can substitute these values in this quadratic equation. X square minus 16x plus 25 is equal to 0. So it is the required quadratic equation.